A wave breaks softly on a tropical shore. White sand glitters under the sun, grains so fine they slip through the cracks of a hand. Each fragment seems eternal, the raw material of paradise itself. Yet its origins are anything but simple. Beneath the turquoise water, a creature drifts between corals. Its jaws snap shut with a muffled crack, crushing stone with the ease of splintering bread. The reef trembles under its appetite. Fragments vanish into the mouth, only to reappear later as clouds of powder. From stone comes dust, from dust, sand. The process repeats endlessly, unnoticed. A beach is being made in secret, one bite at a time. Across the tropics, humans gather on these shores, unknowing. The grains beneath their feet are not inert geology, but a living product of reef biology. For every palm-fringed island and sunlit coastline, there is a hidden architect, one that works silently, relentlessly, reshaping coasts not over millennia, but in every single day of its existence. This architect is the parrotfish. Its strange role in parrotfish reef ecology has become one of the most startling discoveries in marine science. With its fused, beak-like jaws, the parrotfish is capable of gnawing directly into coral. Not for the stone, but for the thin film of algae that grows across the skeleton. Each mouthful strips life from rock, and with it comes rubble, broken into fragments by powerful teeth deep in the throat. This material, indigestible, is ground into a fine powder and expelled as sand. Each fish is a living mill, turning reef into shoreline. Scientists estimate that a single large parrotfish can produce hundreds of kilograms of sand in a single year. Multiplied across populations, their work accounts for tons of pristine white sand, feeding lagoons and shaping beaches that humans see as natural wonders. Without them, tropical sand creation would slow to a fraction of its present pace. But there is a twist. This feeding behavior does not simply recycle matter within the reef, it alters geography itself. Each bite sets off a chain reaction. Coral is weakened, opening space for new growth. Reef surfaces are kept clean, preventing algae from smothering the system. And the waste, expelled behind the fish, drifts and accumulates. What begins as the skeleton of a reef becomes the foundation of a shoreline. The paradox is striking. A single species of fish, often unnoticed, influences the very shape of the land. What seems like destruction, the crunch of coral being shattered, is in fact construction. But how can one animal, scattered across reefs, rewrite coastlines visible from space? Here lies the unanswered phenomenon. Coral reefs occupy only a small fraction of the ocean's surface, yet the beaches they generate stretch for thousands of kilometers. Scientists calculate that parrotfish sand production contributes to the very ground where palm trees root and sea turtles nest. This cycle ties living reefs directly to terrestrial landscapes. Yet not all reefs are equal. In some, sand flows are abundant. In others, they vanish without trace. Why certain populations of parrotfish thrive in ways that generate coastlines, while others do not, remains unresolved. Nobody knows why some tropical islands accumulate beaches at staggering rates, while neighboring reefs produce almost nothing. The animal's appetite appears ordinary, but the consequences ripple outward into the fabric of geography. We stand on shores that may exist only because of their hidden labor. Theories attempt to explain this enigma. One hypothesis focuses on density. Where parrotfish numbers rise, the sand they produce accumulates rapidly, reshaping coastlines. Where they decline, erosion outpaces creation, and beaches slowly vanish. Another theory highlights the type of coral consumed. Not all skeletons grind into the same consistency. Some corals fracture into gravel, while others dissolve into the fine dust we recognize as sand. The feeding preferences of parrotfish may determine whether a beach grows or erodes. A third possibility considers the interaction with ocean currents. Sand expelled into still lagoons settles to form beaches, but in exposed reefs, currents sweep the grains away, scattering them into untraceable depths. The balance between biology and physics may decide whether an island grows or sinks. Scientists still debate which factor holds the key. What is certain is that without coral reef parrotfish, many of the beaches humans treasure might never have formed at all. This realization has forced conservationists to rethink the relationship between reef and land. Protecting parrotfish is no longer about preserving a single fish, but about sustaining coastlines themselves. Their decline from overfishing threatens more than biodiversity. It threatens the material existence of islands. The paradox intensifies. Take away this one species, and paradise may literally wash away. On the shore, the waves continue their endless rhythm. Tourists walk barefoot across sand, unaware of its origin. Each grain they dislodge is a fragment of a reef, ground and released by the jaws of a fish. Each handful is evidence of an ancient process still unfolding, unbroken across centuries. The parrotfish vanishes into the reef, its work untraceable, yet its presence surrounds us in every stretch of tropical coast. The haunting question remains: what if your favorite beach was built by a fish? And what if, without it, the shoreline itself would disappear? The parrotfish is both destroyer and creator, sculptor of reefs and maker of sand. In its silence lies a truth that rewrites what we thought we knew. Paradise does not begin on land. It begins in the bite of a fish, somewhere beneath the waves, where stone becomes dust, and dust becomes the ground we walk upon.